Hello. I ran into this question yesterday, and let's see if we can go over it here. Say that we've been given a input array of distinct integers. Assume that the array is sorted in ascending order. We are given the task of writing a function that will return to us the first integer inside of this list that matches its index value. So for instance, if we're given this input array that begins with -5, we want to return the first number that actually matches its index number. So here, the index numbers would be 0, 1, 2, 3, and 4. In fact, that's the only one that matches. So we will return 4. Keep in mind that it could be more, but we only want to return the first one. So very quickly, you can imagine that we can do this in a straightforward approach and say for I in range of the length of the array. And go ahead and check if array I equals the I, and return the index number. Else, we're going to return, let's say, -1. We could do that, and that should return to us the values 4. Here, the first number is 0, so we know that that's going to be the first index number that matches. 2 here, and when it's an empty list, we'll return -1. So that's pretty easy. That's going to take a time complexity of big O(n). And normally that'd be fine, but we could actually do better. Say that we want to accomplish this in big O of log n time complexity. How we go about doing that? Well, the first thing that we can see here is the numbers are sorted. So with that in mind, we can imagine pretty quickly some sort of binary search option could work. So I've written the index numbers on top of the array to give us a better idea of what approach we might go about doing this. Well, let's think about it. In a binary search, we start in the middle. Depending on whether it matches the number or not, we move to the left or right. So in this case, what information are we given to make our decision whether to search left or right? Well, we can take a step back here. Imagine if the input array started with the number 1. Well, that actually gives us some useful information. That would mean that none of the numbers, assuming that they're all distinct, will ever match the index number because we've already begun with 1, right? So in order for any of these to match, it's either going to have to start with 0 or a negative number. So that's actually very useful. If you think about it, if the number inside of the array is greater than the index number, that means we have to move to the left. If it's the other way, if it's less than the index number, that means we should move to the right. Okay, so that's some useful information. We can say if index number is greater than the integer, and move to the right. Oops. Greater, okay, it'd be move to the left, right? Because we're talking about the index number. And the opposite would be true if index number was less than the integer, then move right. Okay, so that's pretty useful. So recall your binary search. Start at the midpoint. So let's calculate that mid. That would simply be let me think, length of the array divided by 2 rounded down. So we want to make sure this is going to go through a loop. So what's the best way to do this? Well, probably the best way would be to have 2 pointers, one starting the beginning of the index, one showing it at the end. So while start is less, I suppose less or equal to end, because we still want to check even if the start and end is equal, we can say if array of mid equals the mid point, that's the index, then we'll just return the mid immediately. We know it matches. Else if the array of mid is greater than the midpoint, then we're going to move to the right. So what would that mean? We need to change our mid to be because we're moving to the left, we're going to say start will remain the same, and okay, so I've already see here that I'm going to need to actually put this midpoint inside of this loop. So that's not right. We're not going to change the mid here. Instead, we're going to change our 2 pointers. So if we're going to move to the left, we want to change our end. So that's going to be the midpoint. I suppose you can say -1 because I already checked the mid already. And else, in this case, we know that only other possibility would be the number inside the array being less. So if that's the case, we want to change our start to the midpoint added by 1. If we don't find anything, we'll just return an index number of -1, meaning that nothing has been found. Okay. Let's see if this works. Okay, looks like I've entered into an infinite loop. So that did not work. What have I done wrong? Okay. So I see here that's going to continue the loop since the midpoint is going to continually recalculate. So that's not right. What we want to do is find the midpoint using our start and end pointers. So let's try this. Start index plus the end index by that. Okay, we'll enter that. There we go. We passed the first 3 test cases, but lost the last one. It's an edge case. If we input an empty array, we should immediately return -1. So if not array, return -1 to make sure we can fill that edge case. There we go. 0, 1, 2, 3, 4. 0, the first number. 0, 1, 2, the last number. And an empty array. If we do this, we can solve the return the first integer that matches the index number in log n time. So you can imagine if the list was 1,000,000 numbers long, it'd be much more efficient. So that concludes this question. Let me know if you have any thoughts. Thank you.